Hey there, time travel enthusiasts, skeptics, and everyone in between. Welcome back to another mind-bending journey through the cosmos. Today, we're delving into one of the most captivating and perplexing topics ever pondered by human minds. Is time travel possible? Now, before we strap on our imaginary time-traveling goggles and blast off into the unknown, let's set the scene. Time travel has been a staple of science fiction for decades, captivating audiences with tales of adventurers zipping back and forth through history, altering the course of events, and sometimes even bumping into their past selves. But is this fantastical concept rooted in reality, or is it simply a figment of our collective imagination? To answer this question, we need to embark on a journey through the wild and wacky world of theoretical physics, where the laws of nature bend and twist in ways that would make even the most seasoned science fiction writer blush. First up, let's tackle the big question. What exactly is time? Well, strap in because things are about to get a little mind-bendy. In the realm of physics, time is often described as the fourth dimension, intertwined with the three spatial dimensions that make up the fabric of our universe. This concept, known as space-time, was famously popularized by none other than Albert Einstein himself in his theory of general relativity. According to Einstein, mass and energy warp the fabric of space-time, creating what we perceive as gravity. And here's where things get interesting, because space and time are intertwined. Gravity doesn't just affect objects in space. It also affects the passage of time itself. This phenomenon, known as time dilation, means that time can move faster or slower, depending on the strength of gravity and the speed at which an object is moving. Now, here's where things start to get really juicy. If time can be warped and distorted by gravity and motion, could it be possible to manipulate time intentionally? Could we, in theory, build a device capable of propelling us backward or forward through the river of time itself? Well, hold on to your DeLoreans, because scientists have been exploring this very question for decades. One of the most tantalizing possibilities comes from the realm of wormholes, hypothetical tunnels that connect distant points in space-time. Think of them as cosmic shortcuts, allowing us to bypass the vast distances of space and time in the blink of an eye. In theory, if we could find or create a stable wormhole, we might be able to use it as a cosmic subway system, zipping from one point in space-time to another in the blink of an eye. But there's a catch, isn't there always? Wormholes are notoriously unstable and incredibly difficult to create or maintain. Plus, even if we could build one, we'd need to figure out how to keep it from collapsing in on itself or turning us into interdimensional spaghetti in the process. But let's not get too bogged down in the theoretical weeds. Time travel isn't just about wormholes and warp drives. It's also about the fundamental nature of causality itself. If time travel were possible, would we be able to alter the course of history? Or are we bound by some immutable cosmic law that ensures the past remains unchangeable? This question, known as the grandfather paradox, has been the subject of much debate among physicists and philosophers alike. The scenario goes something like this. Suppose you build a time machine and travel back in time to prevent your grandfather from meeting your grandmother. If you succeed, then your parents are never born, which means you're never born, which means you can't go back in time to prevent your grandparents from meeting in the first place. Cue the head-scratching and existential dread. So, does the grandfather paradox mean that time travel is inherently impossible? Not necessarily. Some physicists propose that the universe has a built-in fail-safe mechanism that prevents paradoxes from occurring. For example, Stephen Hawking famously proposed the chronology protection conjecture, which suggests that the laws of physics themselves conspire to prevent time travel from creating paradoxes. According to this idea, any attempt to change the past would be thwarted by some as yet unknown force, ensuring that the timeline remains consistent. Think of it as the universe's way of saying, "Nice try, but you're not fooling anyone." Of course, these are just theories, and the reality of time travel remains firmly rooted in the realm of speculation. But that hasn't stopped scientists from dreaming big and pushing the boundaries of our understanding of the cosmos. One of the most promising avenues of research comes from the world of quantum mechanics, where particles can exist in multiple states simultaneously and seemingly teleport across vast distances in the blink of an eye. Could quantum entanglement, the phenomenon that Einstein famously dismissed as spooky action at a distance, hold the key to unlocking the secrets of time travel? It's a tantalizing possibility, but one that remains firmly in the realm of speculation for now. So, where does all this leave us? Is time travel possible, or is it nothing more than a fanciful pipe dream? Well, the truth is, we simply don't know. The universe is a vast and mysterious place, full of wonders we've only begun to glimpse. But one thing's for sure, whether time travel ever becomes a reality or not, the mere act of pondering its possibilities opens up new horizons of imagination and exploration. So, until the day comes when we can hop into our trusty TARDIS and explore the cosmos at will, let's keep dreaming, keep exploring, and keep pushing the boundaries of what's possible. Thanks for joining me on this wild and wacky journey through the twists and turns of time. Until next time, keep looking to the stars, and may your adventures be as boundless as the universe itself. Stay curious, my friends.